Okay, well, I skipped what should be an obvious step, and I think these are the solutions. There's a question on just why are those the solutions? Well, it's because your matrix equation will be of the form y prime equals lambda y. Okay? Meaning
they were doing something. I don't put that much effort on cheating. It just seems to me like someone cheating.
so lambda y should equal your matrix 2, 1, 1, 2 times y. Or in general, lambda y should equal a times y. Don't really have room to write it up here, so I'll kind of slip it in here. This is the form ay equals lambda y, which is the form a y equals lambda I times y, which is a minus lambda I, y equals 0. Can only have a solution if the determinant of this thing is 0. And that's what leads you to the equations that you get here. So you really want to understand this symbolically and otherwise and how it applies, but you've done it a bunch of times. So next time you do it, make sure you understand all the details, okay? And we've done several examples where we've gone through that, okay? And you want to get it to where it sticks with you. Very important. It comes up a lot of times. Okay? Anyhow, if you do that, I believe you get this. So, and what we're trying to do is illustrate the variation of parameters. So your psi matrix is e to the 3t negative e to the 3t, which is this column vector, right? And e to the t, e to the t, which is this column vector. You can check out that the determinant is non-zero, so the Wronskian is...
Those are all negative exponents, right? Negative t.
No. Don't think so. I mean, you got 4 here because you have a negative 4, right? Okay.
Okay, yeah.
Also, you can plug in 1 here. 1 minus 4 plus 3 is 0. You plug in 3, you get 9 minus 12 plus 3 equals 0. 9 minus 9 equals 0. Okay? Those are all positive. You might be looking at the negative exponent here, and you should be glad that this isn't an e to the positive t, because it would complicate things if this is part of your eigenvector. Okay? Okay, could complicate things. Okay, anyhow, there's your psi. Now the process is very trivial. I mean, not trivial, but very straightforward. And one that, once you solved a number of homogeneous equations, you'll be used to. Okay? Again, you've been concentrating on something besides what we're doing, because you've got a test coming up. Okay?
Well, with your confidence, just think about potential confidence. Confidence interval came out.
Okay?
Negative.
But that's what we've got. Okay? So, once you've worked through the homogeneous equations, none of this will be in the least bit of mystery. So it's very easy to get your psi matrix. You always get a, especially, for 2 by 2 case, you can always solve the characteristic equation because it's quadratic. And once you solved it, depending on whether you have 2 real solutions or 2 complex solutions, complex conjugate solutions, or repeated solutions, we haven't talked about repeated solutions yet. That's a curveball that we'll take care of after you've taken your test and can really concentrate on this. We're doing the easy stuff. And you wouldn't think variation of parameters is easy stuff, but you saw how easily we got the formula. Now, you might be things you don't remember and don't totally understand about matrix functions, but it's all straightforward. Okay? So you want to make sure you really understand it. But anyhow, here's our psi. So you understand that once you have the variation of parameters formula, which ideally you can very easily derive if you happen to forget it. There's a premise and the setup is very straightforward after you've looked at it a few times. Then you can start with an equation like this, solve the homogeneous equation. If it's a 2 by 2, you can certainly do it. Okay? And if it's a higher order, well, you're probably going to go to machinery to find the solutions in any real world situation where you don't have an obvious root that you can divide in and so forth. Okay, so anyhow, those are all just algebra level details. You can solve the equation, you get this. You do want to understand this step, how I got this. I'm not 100% sure this is right, but I looked at it twice, I'm pretty sure it is. Because it's really easy to plug these eigenvalues in here and see what your equation is going to be to determine A and B. Okay, so again, from here to here, really easy. Then, helps to remind yourself of this because it connects you back to the derivation.
You're going to get paid more because you got a unique skill set, correct? All right, that's what I would think would happen.
Okay? And what's psi inverse? Well, the determinant of this thing is 2e to the 4t. 2e to the 4t. Okay? So I'll write the determinant of psi.
I don't remember how to find the inverse of 2 by 2.
Is 2e to the 4t. So if you switch these and change the signs of these and that stuff, you can easily invert a 2 by 2 matrix, right?
Yeah, how do you do it? I don't remember the details.
I don't either. I just do it by trial and error. Or I row reduce a general 2 by 2 matrix to remind myself, right? I'm hypothesizing that you switch these two and change the signs of these two. But I don't care. I really don't care because I have several methods to rederive it, right? So I don't bother remembering.
I think we went through this in linear algebra.
And that's one of the things, I'm not sure that's good, but you see, as my working memory decreases with age, I rely more and more on rederiving things. When it gets to the point where I can't rederive things, then it's time to retire, isn't it? Okay? And in the meantime, I get to emphasize to you the advantages of starting with a small nucleus of premises and a little bit of technique and being able to proceed from there rather than try to remember 10,000 formulas, which is the engineering approach. And nobody remembers them, everybody now Googles them, so nobody understands them.
Well, we just get formula sheets. So
Huh?
We get formula sheets.
Yeah, and I don't know when formula sheets started. They certainly weren't there when I was miseducated.
Right here. All of that.
It's ridiculous. It's ridiculous. Maybe not for engineers because there are way too many formulas and many of them can't be rederived, easily derived. They're empirical. Okay? So I don't necessarily argue with that.
Yeah.
I can't believe that
I think it's pretty neat.
physics tests are often accompanied by formula sheets. okay? Even MIT's tests, but MIT's tests are so hard and the formula sheet is so brief that it really doesn't hurt. Now, I got to use a formula sheet in atomic and nuclear physics, first time I ever saw it, and I got to make it up. Anything I could write on a 1 by 1 inch sheet of paper.
For real?
Okay?
That's a tiny piece of paper.
You don't need that many formulas, and it caused me to
Yeah, but it's like
It caused me to think about what I was going to put on that thing to the point where I didn't need the formula sheet anymore. Okay? And I wasn't a spectacular student in that course. I made a B. It was in McGurvey's. McGurvey's got one of the standard texts. It was his course. He was teaching it from his notes that developed into his text. So, McGurvey did it, then I got to respect it. Okay? It became one of the major texts in introductory quantum mechanics, basically. And I was glad that he gave us that option. And the problem was all the 4 pi's and 2 pi's, are they in the numerator, are they in the denominator? How do you determine where they are? Well, duh, if you understand where the formula comes from, it's obvious. Okay? Or if you got a half-decent memory. And, I could memorize formulas. That wasn't a problem. But I found that it was much easier to just know where everything comes from, to the extent that was possible. Now, obviously, you get to the point where you can't rederive everything. When you're at the point where you're working with formulas, it means you don't really understand what you're doing, but you can still probably do it if you don't have to go too much deeper. So that's kind of it. But engineering, again, is different because there's so many empirical formulas. Now, the fundamental formulas that are basically physics, I think you'll be a better engineer if you don't have to memorize those formulas, if you know where they come from. Most engineers don't know where they come from.
Yeah.
The best ones do. The good ones do. Okay? The best ones do, and they know more than the physicists sometimes. Okay?